So in previous slide something went wrong at this when I was explaining the third mutant. So I'm writing it again. So let's suppose for first mutant the genotype is A, B, C, D, and A is mutant. So this is genotype of haploid fungus A. Similarly, I am taking haploid fungus 3. It also has A, B, C, D gene. All are very important for formation of histidine or arginine. But in this case, B is mutant. Let's suppose B is mutant in this case. When they will be mated and when they will be in diploid state, the diploid state will be like A, B, sorry, it will be like A, B, C, D is mutant. For in diploid state it will like A, because 3 will also contribute now, B, C, D. Here B is mutant. So in this diploid state, for normal A, normal A can come from this side from mutant 3, and normal B can come from mutant 1 in from the diploid state, and they will retain the prototrophy. So I guess this will make some sense of what I'm trying to say. Now see, when second number and third number, when they were mated, you are getting negative. You are getting negative. Okay. So this means that the mutation can be in the same gene. Mutation can be in same gene. So I'm taking a fresh example here. So second number mutant and third number mutant. I'm taking a fresh example here. What I'm trying to say is that A, B, C, D, A. This is a fresh example. B, C, D. Now in both the mutants, so mutation is in B in second number mutant, and mutation here also is in B in third number mutant. But in previous example, in previous slide, I showed that the mutation, when we were going step by step, I thought that the mutation is in some other gene. I took C there, but don't get confused. I'm relating all these things, and please try to look this example. That what I'm trying to say is that because when we mated second and third, they gave, when we mated second and third, they give a negative. They give a negative here. So this is because the mutation is in same gene, which is B. So we can get normal A, we can get normal C, we can get normal D, but we are not getting normal B. So, and as I just said that all are equally important. A, B, C, D have to be functional. So there will be no arginine and they will retain the auxotrophic state. Here a negative sign in second number means that here the selfing, or the second number mutant was mated with the second number mutant, and the mutation was on same gene, which was, let's see which is, this is second number mutant, when they were mated, the mutation was in B, so the state was not retained, it was in negative state, in auxotrophic state. So this means that the second mutant and the third mutant which are generated, so the second mutant that you generated and third mutant that you generated are the same mutants. They are the same mutants because they are having the mutation in the same gene. But yes, in the same gene also the mutation can be. So let's suppose this is B gene. So this is B gene. And we know that in both the mutant second and third, culprit is B gene mutation. What I am trying to explain you that in this, the mutation in second number mutant can be in, no doubt it's in B gene. It can be here at this locus because gene are big. The size of the gene can be in KB, can be in NB also. And for mutant 3, it can be in this region, or it is very much possible that the mutations for both the mutant for second and 3, they are at the same locus. So what I'm trying to say that because second and third, when they were mated, they give negative sign. This was implying that the mutation is in the same gene, which is B. What I'm trying to here explain is that although the mutation is in the same gene, it can be because it can be possible that in second number mutant the mutation was at some other point of gene of locus gene B, and the mutation in mutant 3 is also in gene B, but the site is different, or it can be the site can be same. But the take home message from is this, the concluding thing is this: the mutation is in the same gene, so they were not able to complement. And yes, they were not able to retain the prototrophy straight. Here, negative sign. Here, negative sign means the selfing, or the third mutant was crossed with third mutant, and we know that the B gene is mutated, so I'm saying third gene is crossed with third gene, and state was not regained. Now see the fourth number mutant. Here, when the one number mutant was mated with four number mutant, we got negative sign. It's very much possible that here the mutation was in A gene, so the mutation was in A gene for 4, because when they were mated, they were not able to retain, they were not able to get the prototrophy trait. So the mutation is in the same gene, but the position can be different. The mutation in the same gene can be at different locus or at the same locus also. We are not going into it, but what we want to understand is that whether the mutation is in same gene or not. It hardly matters that it is on different location or it is at the same location, but it is for your purpose, for your clarity. I'm just explaining all these things. Mutation in A means that the A is not functional, and the negative in this and the negative in this, when 1 and 4 were mated, means that the mutation is in the same gene, which is A. Similarly, when you see a negative here, when a second number mutant was crossed with fourth number mutant, a plus sign is here. This means the mutation is at some other gene. So mutation is not in B gene. It can be at C. Similarly, if you see the third, because the mutation in the second number mutant and third number mutant was in the same gene, which was B, so when third number mutant was crossed with 4, the prototrophy state was there, because in second and third the culprit gene was B. For 1 it was A. Okay, so this means that the gene mutation which is causing gene mutant 1 and mutant 4 to give arginine oxotrophy is the mutation in gene A. The mutation in gene 2, the mutation in mutant 2 and the mutation in mutant 3, the mutant gene is B. Okay. Now fifth, when 1 was mated with 5, we got plus. Okay. When second, so here second means second was mated with 5, we got plus. Third was mated with 5, we got plus. Fourth was mated with 5, we got plus. But when 5 was crossed with self, it was negative. So this is first number mutant mated with 5, second number mutant mated with 5, third number mutant mated with 5, fourth number mutant mated with 5, and fifth number mutant with self. So here it was negative. So this means that, so what does it mean? because 1 number mutant and 4 number mutants are same, so I'm writing them in one go. A, B, C, D. A was mutant. Similarly, 2 and 3 are same, so I'm writing them together now. A, B, C, D. In them, B was culprit. Now, fifth number came. So first, we have to always look into the selfing part. So this is the selfing part. So what selfing says that when A, B, C, D was crossed, when the mutant 5 was crossed with mutant 5, there was no plus state. So it is very much possible that the mutation is in gene C. So now when 1 will be crossed with 5 in 1, A is only mutant. Here A is mutant, and in 5 C is mutant. So C can be given by normal C in 1, and here A can be given by normal A of 5. Similarly, for 2 and 3, the mutant was B, so normal B can come from 5, normal B can come from 5, and normal C can come from normal 2 and 3. So that's why when 1 and 5 were mated, they will give 4 plus. When 4 and 5 were mated, they will give plus. When 2 and 3 will be mated, they will give plus and plus. So this means a C gene is mutated in fifth number. Some other gene, a third gene is involved here. And I hope now you can calculate for this. You will find that a gene D is mutant in sixth number mutant. Rest, when you mate 1 and 6, it will be complemented. 2 and 6 complemented, 2 and 3 and 6 complemented, 4 and 6 complemented, 5 and 6 complemented, but 6 is not complemented. So this means there is some other gene also, one more gene is also there, which can be D. So similarly, you have to solve all these things. So from this problem, we found that for arginine biosynthesis, 4 genes are involved: A, B, C, D, and if any of the gene is going to be mutated, then the arginine biosynthesis is not going to be found. Remember, initially we have said that for formation that we create the mutants having the same phenotype, and the phenotype was that they were all deficient in arginine biosynthesis. They were all arginine auxotrophs, but all these 4 genes, like A, B, C, D, when they will work together, then they will be able to form a functional arginine biosynthesis will be there. So if we took 1, 2, 3, 4, 5, 6 mutant out of 6. When we compared these 6 mutants, we found that the mutant 1 and mutant 4 are same, mutant 2 and mutant 3 are same. So mutant 1 and mutant 4 will be in one group. They will be in one group because the mutation was in the same gene, which was A. Similarly, the mutation in 2 and mutation in 3 was in same gene, so they will be in same group. So they will be in same complementation group. So 1 and 4, they have the same type of mutation, so they will be in same complementation group. So complementation is something different from complementation group. I'm grouping those which is giving the same I'm grouping those in one category which have the mutation in same gene. So mutant 1 and mutant 4 will be in one group because they have a mutation in gene A. Mutant 2 and mutant 3 will be in one group because they have a mutation in same gene, whereas 5 and 6, they will be not in any complementation group here because the 5 has a different mutation, because the gene C was there in because gene here C was involved, whereas in 6 a D gene was involved. So here we have looked into that, how we decipher that how many genes are involved in a arginine biosynthesis, or how we can similarly correlate, and similarly we can find the number of genes which are involved in different pathways. So these, so from this diagram, it will be very clear what I was telling. So let's suppose this is mutant 1, this is mutant 2. We know that in mutant 1, gene 1 was mutant. So let's suppose this is gene 1 is A, gene 2 is B. Gene 1 is A, gene 2 is B. So in mutant 1, because they I'm saying in haploid state, I'm talking about haploid state. So here the gene A was not functional and B was functional. So they were only B was functional. So they were oxytropic. I'm not taking all A, B, C, D. I'm taking only A and B. I'm taking an example of only two gene here, A and B. Here A is only not functional, B is functional. They will be inorgotropic. Whereas if you see this mutant 2, whereas in this case the gene B is mutant, so alone they are oxytropic. But in diploid state, a fungus in a diploid state, so this is a diploid state. We have the two chromosome of for here. Now they are in diploid state, so gene 1 functionality can be gained from this mutant 2 chromosome, and gene 2 functionality can be gained from chromosome from mutant 1. So diploid from mating mutant 1 and mutant 2, and that's why they are giving prototrophic state, that is a plus state. So this is complementation between two haploid mutants when combined in a diploid state. So this is the analysis. So this is the analysis that talks about that we discussed in those diagrams. I guess you can look into this, and this is same, and these are the references. Thank you.